Okay, now we're back with the lymphoid organs. I think I mentioned I really like this picture. I can't say that enough. So a couple of lymphoid organs or groups of lymph tissue are going to be your pharyngeal tonsils and your palatine tonsils. Your thymus, that actually produces, or where the T cells mature. The spleen, where red blood cells go to die, and you've got the appendix, which is a nursery for your probiotics, the Peyer's patches in your small intestine that are your gut associated lymphoid tissue and your mucoid associated mucoid tissue. Next. The function of your spleen: cleanses the blood, filters, and it goes through phagocytosis. It destroys old red blood cells, like we said, produces red blood cells before birth, so it's a reservoir for blood as well. Your thymus plays a key role in early immune system development. It's a site of T lymphocyte maturation, and it shrinks after puberty. So a big thing to know about MALTs and GALTs. MALT stands for mucosal associated lymphoid tissue. It's an important barrier against infection, of course, because, you know, your gut is dark and moist, and it's the perfect place for all things to grow, right? So it's found in portions of the digestive, respiratory, and urogenital mucosal linings, and it helps destroy foreign contaminants by means of phagocytosis and producing antibodies. Now, MALTs is a broader category of gut-associated lymphoid tissue, which is a GALT. GALTs are concentrated in the Peyer's patches, appendix, and the tonsils. So that brings us to tonsils. There's the pharyngeal tonsils or the adenoids, and then there's the palatine tonsils and the lingual tonsils, which are part of the tongue area. Couple things we should know is your lines of defense. There's the innate barriers, which is your first line of defense, which is your skin, mucus membranes, body secretions, and reflexes. Innate cells and chemicals like phagocytosis, natural killer cells, inflammation, fever, interferon, and complement cells, which is your second line of defense. And your third is going to be the adaptive immunity, which are the T cells and the B cells, or the humoral immunity piece. Now, please know these lines of defense because I will ask for them. There you have it again. Innate barriers, your skin, first line. Mucous membranes, body secretions, body reflexes like sneezing, coughing, vomiting, and diarrhea. So it's the releasing or the prevention of adherence of the bacteria and such, so that, you know, you don't ever get a chance to come into the body. Second line, we're going to talk about they ingest pathogens, cellular debris. So you've got your neutrophils and your macrophages and your natural killer cells. Natural killer cells are pretty awesome because they only look for whether you're a friend or your foe. So do you belong to us or don't you? And if you do, great, we'll let you slide. And if you don't, they go after you on sight. So that's pretty amazing. And then you have the interferons, or a group of substances that prevent nearby cells from producing more viruses. Complement is a specialized protein in the blood that kind of binds to the that are activated by immune responses. Amazing stuff. It binds to foreign cells to facilitate phagocytosis. It kind of tags them for inflammation. And it tags them for other cells to come and get swallowed up. Like, oh, hey, this doesn't belong here. You see that? Whoa, this lysosome. So there you go. Dun, dun, dun. Inflammation, interesting factoid you should know about it is that the inflammatory reaction, you should know exactly what happens in that reaction, which is on this slide. Inflammation is an interesting thing. Please remember that the first step of all healing processes is, in fact, inflammation. And so it can result from infection or tissue damage or what have you. And you get the heat, the redness, the swelling, and the pain. The cells release histamine. Leukocytes enter the tissue. So it's the white blood cells, which are the granulocyte macrophages and the mast cells. The leukocytes and plasma produce inflammatory exudate. So then the pus is produced and nearby lymph nodes enlarge. Okay, so then this whole thing, everybody's, no one likes it. When this is all happening in your body, it doesn't feel amazing, but it is, in fact, the first step to all healing processes. So it's not something that you should just stop all the time. We've become kind of anti-inflammatory happy. Yes, it does cause pain, and you need pain to be able to heal as well. So it is a rather delicate balance. So these are, it's a cool picture. It's not amazing. It's not one of those things where I'm like, I'm going to put this on your test. But it is a very good slide to know. Innate immunity fever as phagocytosis happens as the phagocytes work. They release substances that raise the body temperature. This stimulates the phagocytosis and it increases metabolism and decreases some organisms' ability to multiply. So fever is so often used as like a self-cleaning oven feature. It just kind of it runs double duty. It allows for your immune system to work overtime and more optimally, and it also kind of suppresses everything else we don't want to multiply quickly. Adaptive immunity. So it's the power to overcome a specific disease agent. So this is the third line of defense. Characteristics are that specific response to specific pathogens. This is acquired over a lifetime. It's stimulated by antigens, and this is how we form. It's by forming antibodies, foreign substances that induce immune responses to certain lymphocytes. So the agents that are involved are going to be the T cells that are also called cytotoxic T cells, which do kind of more like hand-to-hand combat. So this is the ones that attack individual cells. Antigen-presenting cells are the ones that identify something, they engulf it, and they present it out there. And so it shows, hey, this is shows the immune system cell members that, hey, this is what's out there in your body. Then you have the B cells that actually are in charge of humoral immunity. They even so humoral meaning blood, and the B cells also have memory cells, which keep track of all the pathogens that you've been exposed to in the past. Oh, there you go. T lymphocytes originate in the red bone marrow, mature in the thymus. T stands for thymus, become sensitized to specific antigens. There's 4 types: cytotoxic T cells, they kill infected cells directly; helper T cells that secrete cytokines; regulatory T cells; and memory T cells. They are stimulated by APCs, or antigen-presenting cells, which include macrophages and dendritic cells. They're the ones that kind of show the T cells like, oh, hey, we just want you to know that this is happening. So this is how T cell activation works. You've got the dendritic cell that brings it in, the foreign antigen. Then the phagocytic vesicle and the lysosomes kind of split everything up. Then it chops the antigen up into tiny, tiny pieces. And then it brings it out and goes, oh, hey, this is what's happening. So the dendritic cell presents the antigen fragment with the MHC to the helper T cells. Then the activated helper T cells produce cytokines, which stimulate other leukocytes. This right here, beautiful people, T cell activation. You know how to see there's 1, 2, and 3 steps. You should be able to put them in some kind of order. And then that's another 10-minute segment. So go, evacuate, caffeinate, hydrate, and feed yourselves. And then we'll come back with B lymphocytes and humoral immunity.